Hello everyone, welcome back to our SOLIDWORKS course. In this video, we would be creating another 3D component using a sheet metal tab. Let's take a look at what our component is. You can see here that this is the component we would be generating using the sheet metal tab. This component has a few more features than we created in the previous one. Also, you can see that the flanges generated in this video are a bit complex, but you need not worry, we would be creating this 3D model in the simplest way possible. Let's move to SolidWorks and start with our modeling. We will launch SolidWorks and then create a new part. Once we are into the new part, we will begin with our sketching. We will create our first sketch on the front plane. Once I am into the sketch mode, I will select center line and then create a center line in the between. This component or the base flange of this component is symmetric, so we will take advantage of that. I will create a line over here which is horizontal and then again create a vertical line and end this line on the center line with the help of horizontal line. We have created 3 lines over here. Now we will start defining them. First, I will set these 2 points as horizontal so that I have my origin at the bottommost point of this plate over here. Now next, what I will do is that I will specify the distance of this line as 40 millimeters. But in the finished component, I want this distance to be 41 millimeters. As our thickness for the sheet metal component is 1 millimeters, we will leave a tolerance. In this case, if I extrude or create the thickness on either sides, I will have to specify the thickness of this line over here as 1 millimeter less. I will show you why with the preview that will be shown while we create the base flange. Next, I will specify this with a diametrical dimension. This is 95 millimeters. Once I have entered this, you can see that my sketch is not yet fully defined. There is this point that has not yet been defined. We will specify, again I was still in a diametrical relation or dimension and the center line was still selected. I will press escape and then exit diametrical dimension. I will specify the length of this line as 22 millimeters. We will make a slight change over here. Since I want this as my bottom face and in line with this origin over here, what I will do is I will make 95 as 93. I will reduce 2 millimeters because as our sheet metal thickness is 1 millimeter, it will be added on the both sides, that is 1 millimeter over here and 1 millimeter over here. I will explain it to you how. First, I will mirror all these entities. I will select mirror entities and select all of these 3 entities with the help of box selection. Then you can see here that this line has not been added because we selected all of these by dragging our cursor from top to bottom and only the half of this line was inside this box. Again, I will move my cursor over here and then select it using the box selection. Now I will press the right mouse key and then move my selection from entities to the line about which I want to mirror. I will select this line and again without moving my mouse, I will press the right mouse key. You can see here that my mirror has been generated. Now here I will explain you why I was asking you to make this dimension as 93 as opposed to the earlier dimension that was 95. If we go to sheet metals and from here we will select base flange, you can see that this is how our material is being added. I will press the space bar and then set it. We can do it from here as well. Now you can see that when my material is being added from on the either sides, 1 plus 1 mm would be added in this dimension. That is, now this would be 95 in total. Also, here in this case, when I specified this line as 41 millimeters, when I wanted the total height of this base flange to be 41 millimeters, you can see that why I did this over here. Again, 1 millimeter would be added here. Now from the direction, I will specify this as the mid plane. And in the distance over here, we will specify 32 millimeters. I will press Ctrl 7. I will rotate it normally. You can see that this is how my sheet metal preview is being shown. From here, I will set the sheet metal parameters as 1 mm thickness and 1.5 mm bend radius. We will take the K factor in this example as 0.5. Now that we have entered all our sheet metal parameters and here we know on which direction our material is being added, we can click on OK and generate our sheet metal base plan. If I press Ctrl 7 and set it to isometric, you can see that our base feature is now ready. Next, what I will do here is that I will select this face and then start sketching on it. I will press Ctrl 8 in order to set it normal to the screens. Next, I will select a corner rectangle and create two corner rectangles over here like this. Once I have done this, I will use my dimensions in order to define it. Here you need to be careful because there are a lot of edges due to the bends. I want this edge over here and the distance of this line from this edge over here is 19 millimeters. And next, I want the distance of this line from that edge over here to be 27 millimeters. Once I have done this, I will rotate my model a bit in order to show you from what edge I was selecting. This was the edge from which I was selecting, as I wanted to give these dimensions from the extreme face over here. If I had selected the extreme left edge, it would have been this edge, and that would have been a wrong selection. So you need to be very careful while giving these dimensions from edges when you have bends over here. Next, I will specify this height or this distance or the distance of this line from here. It is 44 millimeters. What I will do is that I will press Ctrl 8 again and set it normal. Now I will start defining this rectangle we have over here. For this, I know that the distance from this edge over here is 20 millimeters, and then next I know that the width of this rectangle over here is 27 millimeters. I will enter 27 and then press enter on my keyboard. Now you can either give this height over here or you can simply press escape and exit your smart dimensions. Select these two lines and make them collinear. Once you have created the basic sketch, what you can do here is you can again go to sheet metal and from here you will select base plans. And you can see that again your material is being added. Now I want the material to be added in the downward direction. If I specify reverse direction, it would be added on the top part. But I don't want that here. I will again untake reverse direction, and this is the right direction of generation. Here, I will simply click on OK, and you can see here that my part has been added. Now, there is another way of creating these sketch. What you can do over here is that I will first roll back to eliminate this feature. Now what I will do here is that I will create a plane over here like this. Let's say I create a plane at a distance of 27 millimeters. I will enter 27 and then reverse it. Once I create this plane over here, I now have this plane. I will select this plane and then start sketching on it. I will press Ctrl 8 and then set it normal. Now you need to first make sure that this was the edge from which my flange would have been created. I can simply click on here. I can now start creating a sketch. Let's say I create a sketch over here like this. I will end my sketch. Now I will go to the smart dimension, and here I know that the dimension for this line over here is 44 millimeters. And next I will also specify the height of this profile, that is 19 millimeters. You can select this line and give it a dimension of 19 directly. Once you have done this, what you will do is that you will again go to sheet metal and then select base flange over here, and you can see that your base flange is now being created directly. This is another way of creating this feature that I showed you. From the direction over here, I will specify the extrusion width, that is 8 millimeters. I want this to be extruded for 8 millimeters. Now I will not specify all these dimensions or these options over here because I want them to be by default selected. This was the only thing that I had to do. I will simply click on OK and you can see here that my part has been generated. But you can see here that in the cut list over here, we have two separate parts. That is one, which was our base plans, and second, we have another base plans over here. But if you notice, if I suppress this base plans over here and then roll forward here, you can see that this is one part over here. So if you create your tab using directly this command, it will be a part of your, or it will be connected to your sheet metal part. But if you create by using the method that I showed you in the second part, this would be a different part. For that, you will have to go to insert, and from features, you will have to select combine. Then again, you will have to select both these bodies and select add option from over here. If you click on OK, this would be created in one single part. This is how you create your part or your flanges over here in two different ways. Now that I have shown you how to create this, what I will do is that I will first select these two and then suppress both of them. We will create it using the first method that I showed you. Now again here, what we will do is that we will select the edge flange and normally create an edge flange over here. I find this a very easy and quick method, but if you find the other method easy, you can use that. It is always the designer's perspective in order to create a 3D model. I will specify the height of my flange from here as 19 millimeters and then I will simply click on OK. This is how you can see that my edge flange is being generated and still there is one single component that has been generated. If I click on this over here, you can see that this is one single part. Next again, I will add another edge flange from this edge over here. I will first exit it and then hide this plane. It is always a good practice to hide all the things that are no longer necessary. I will again go to the edge flange and select this edge and then drag my edge flange downwards. From here, I will specify the distance that I want for my edge flange. I want this till the bottommost face, so I will specify this distance as 41 millimeters. Once I have done this, now if you remember when I had shown you the reference picture, this flange was not as straightforward as seen over here. It was having a bit more features on this edge over here. I will show you how do we create that. For that again, I will select this edge and say edit flange profile. From here, it again gives us the options in order to specify the flange profile. From here, I will simply select a line and then start sketching. But before that, what I will do is that I will set it normal to the screens. It has turned around this way. I will use the space bar. It is not allowing me. I will press back and from here, I will say that set it normal or I want to view this component from this direction. What I will do here is that again I will select this edge and select edge flange profile. Once we are into the sketch mode, we can use our sketch entities like normal. I will create a horizontal line over here and then an inclined line, take it upwards, bring it again back and then join it over here. Here I made a small mistake by making this coincident on this line. I will delete the coincident over here and drag my line here. Again, I will create a vertical line up till this edge. Now I will press escape and using the dimensions, I will start dimensioning my sketch. I want this distance. As told earlier, it should be 41 millimeters. Next, I want this distance from this edge over here to be 13 millimeters. I will add 13. Next, this chamfer over here needs to be of 6 millimeters. I will select this and give it a dimension of 6 millimeters and I will specify the angle between these two entities over here as 45 millimeters. So now this horizontal distance will be 6 as well according to geometry. You can see that if I select this or add this dimension, it is telling me that this is over defining a sketch. You can see here it is now suggesting me to make this dimension a driven one instead of a driving dimension. If I click on OK, you can see that this dimension is now a grayed out one, showing that this is no longer a driving dimension but rather a driven dimension. Once we have done this, we will move to the next part. I will specify the distance of this line from this topmost edge as 19 millimeters. I will enter 19 and click on OK. Here we have been specified that the distance between these two lines is 10 millimeters. Once we have done this, you can see that our sketch is now getting fully defined one step at a time. Next, I will specify the distance between these two lines as 19 millimeters. Once I have done this, my sketch is now fully defined, and now I have to simply trim off the excess entities that we no longer need, like these ones. You can see that now my flange has taken its shape and it is now ready to be created. I will click on finish over here, and you can see that once I clicked on finish, a flange has been created according to the shape I sketched on the face. This is how you can create a flange in any shape you want by using the normal sketch entities that we have learned so far. Again, I will create another flange from here. I will go to the edge flange and then simply create another flange over here. The distance of this flange would be 30 millimeters. I will simply enter 30 over here, and you can see that in the preview it is showing us how the edge flange would be created. From here, I will make sure that the material inside option is selected. Now I will click on OK, and you can see here that my flange has been generated. Now our 3D model is almost ready. What we need to do here is that we need to add two holes on these two surfaces. I will show you how do we add holes by using this command that says simple hole. If I select simple hole, it is asking me on what face do I want to add the hole. I will specify this as my face, and now here it is asking me how deep I want the hole to be created. In this case, I can simply select through all, and you can see here that in the preview it is showing me that the hole would be cut through all of this material over here. And here it is asking me to specify the diameter of my hole. In this case, I will simply press on 8, press enter 8, and you can see here that the diameter is changing instantly. I will click on OK, and you can see here that my hole has been created, but I did not define my hole. If I want to do that, I will right click over here and go to edit feature. Now, my mistake, I will right click on this hole over here and say edit sketch. You can see over here that my sketch for the hole is being shown. You did not have to create the sketch in the first place and then go to extrude command and then extrude it. You simply specified it over here, a sketch was created. Now you have to simply specify the dimensions of the center that you have. The center of this hole is at a distance of 8 millimeters from this extreme top edge, and the center is at a distance. I will get back to the smart dimensions command. The center is at a distance of 9 millimeters from this edge. I will zoom in order to get a good view of the center so that I can select it quickly. I will select this edge over here and then give them a dimension of 9 millimeters. Now you can see here that it is showing us that my sketch is fully defined. I will simply press Ctrl Q and exit the sketch and rebuild this part. Now you can see that my sketch, or rather this whole here, has been aligned according to the way I wanted it. Again, we will say select a simple hole. I will specify this face over here, and then you can see that it has added a hole. From here, we will say up to next because I don't want to create this hole through all. I will specify the diameter of my hole as 13 millimeters over here. I will enter 13 and press the enter key, click on OK, and you can see here that a hole has been created. But if I press spacebar and take a look at our holes from the top, you can see here that the holes are not coaxial. You can clearly see over here, but if you want to verify, I will select this surface over here, that is the inside surface of our circle, and press Ctrl and select the inside surface of this circle over here. Here it is showing that the distance between cylinder axes are 5.44 millimeters. Now we will specify the distances and then we will take a look at how our holes have been aligned. I will select this second command over here and then select Edit Sketch. From here, I will get into the Smart Dimensions command. You can specify all the distances that this circle have. But let's say you don't want to specify all the dimensions and you think that it is a very time consuming process. I will press Escape and exit the Smart Dimensions command. I will now set it normal to the screens by pressing the spacebar and getting it normal to the screens like this. Now from here, I will go to the drop down over here and then select a wireframe model. Hidden lines removed. This is not the model, this is the model that we want, a wireframe model. You can see that now this whole layer is being shown. What I will do is that now I will select Convert Entities, select this hole over here and convert its entity or convert the edges onto a current sketch. I will press OK and now I will set this circle as my construction geometry. I will again click on it and then fix it over here. It was over defining my sketch, so I will press Ctrl Z. If I try to move here, you can see that this is already fixed at its place. Now I will select this circle that was defining a circle or hole of 13 millimeters. I will press Ctrl and select this sketch entity that we have recently converted and we have made it a construction geometry. I will select both of them and from here I will say make concentric. You can see here that directly my hole has been shifted at the center of this circle over here. This is how you can use referencing while creating your 3D models. You need not specify the dimensions every time you create your 3D models. If you have created some feature previously, you can use its reference and to create further features. This was a small example of how you can create these references. And now that I have set it concentric with this circle, you can see that without giving any other dimensions, my sketch is now fully defined. But you need to make sure that this sketch would not move, or rather if you move this sketch over here, this hole will also move along with it because we have set it normal, or we have set the references between these two over here. Now again, I will go to the first option that says shaded with edges. And if I press Ctrl Q, you can see here that this is how my hole has been generated, and now these two holes are coaxial. If you want to verify this, what you can do over here is that you will select this inside surface of this circle over here, rotate my geometry, press Ctrl and select this inside surface over here. If you read here, it says that now the cylinders are coaxial. Thus, we can confirm that these two cylinders are now coaxial and there is no distance or there is no displacement between the centers over here. I will press Ctrl 7 and here you can see that this is how we have created a sheet metal component using all the features like edge flange and simple cut over here. I hope this was a very good example and you learned about how to use sheet metal components and also how to use references in order to create your further features. I hope you're having fun learning about sheet metal components. I will see you in the next video.